Today you stop learning cybersecurity and start doing cybersecurity. You're about to build your first real security operations center. Welcome back to TechSky, and welcome to something special. This is not just another tutorial. This is the beginning of your transformation from a curious learner into a professional SOC analyst. Today, we are building the foundation for everything that comes next in this series. We are creating a complete blue team lab environment that simulates a real company's security infrastructure. Think of this as your personal cybersecurity training ground, where you will practice defending systems just like professionals at Fortune 500 companies. Here's what we're building today: 3 virtual machines working together as a unified security monitoring system. The first machine is your watchtower, an Ubuntu server that acts as your main security operations center. This is where all your defensive tools will live, where monitoring happens, and where you'll see everything. The second machine is an Ubuntu Desktop. In our simulation, this represents a DevOps engineer's workstation inside the company. The third machine is Windows 10, representing a designer's workstation. These 2 endpoints are what you will be monitoring and protecting throughout the entire series. Let's build this together. Open your web browser and search for VirtualBox. Click on the first official link, and you will land on the Oracle VirtualBox homepage. Click the large download button. You will see options for different operating systems. I am on Windows 11, so I'm clicking Windows Hosts. The download will begin. While it downloads, let me explain why VirtualBox is perfect for what we are doing. It creates completely isolated environments that are safe for security testing. If something breaks in a virtual machine, your actual computer is completely unaffected. This is exactly what we need for practicing defensive security. Download complete. Click the installer. Click Next through the welcome screen. Accept the license agreement because we trust Oracle with VirtualBox. Click Next on the custom setup screen. It will warn you that network interfaces will be reset briefly. That's normal. Click Yes. If it asks about installing missing dependencies, click Yes, and then click Next with all checkboxes selected. Now click Install and watch the magic happen. The installation wizard will extract files, configure drivers, and set everything up. When the installation is complete, make sure the checkbox says Start Oracle VM VirtualBox and click Finish. VirtualBox launches. Now we have our foundation ready. But here is something important. We are going to switch to expert mode because you are not learning to be an average user. You are learning to be a professional. This gives us more control and more options. Now we need to get our operating systems. A security operations center needs 2 types of systems: your monitoring infrastructure, which will be Ubuntu Server, and your endpoints, which will be Ubuntu Desktop and Windows 10. Let's gather everything we need. Open a new browser tab and search for Ubuntu 22. Click on the official Ubuntu website link. I know Ubuntu 24 exists, and yes, it is newer. But here's why we're using Ubuntu 22. This is the version you will find in most real security operations centers right now. When you get your first SOC job, there is a very high chance you'll be working with Ubuntu 22. So we are training you with industry standard tools. On the Ubuntu page, you will see 2 options: Ubuntu Desktop and Ubuntu Server. We need both. Click Download on Ubuntu Desktop first. This will be your DevOps engineer's workstation in our simulation. While that downloads, click Download on Ubuntu Server as well. This will be your watchtower, your main SOC infrastructure. Another download begins, and now both of them are downloading simultaneously. We still have one more operating system to grab. Now for the final piece of our puzzle, Windows 10. This will represent a designer's workstation in our company simulation. Open another new tab, search for Windows 10, and click on the official Microsoft link. The page loads, and Microsoft wants you to download their media creation tool first. We're not doing that. Here's the trick. Right-click anywhere on the page and choose Inspect. This opens the developer tools. At the top of the panel, You will see an icon that looks like a phone and a tablet. Make sure it is enabled. This is the device toolbar that makes websites think you're on a mobile phone. Now refresh the page. Watch what happens. The page completely changes. Microsoft now shows you direct download options because it thinks you're on a mobile device. Close the Inspect panel. Scroll down until you see Edition selection. Choose the Windows 10 ISO and click Confirm. After that, select your language and click Confirm again. Now it will ask for your system architecture. Choose the one that matches your system. Most modern computers are 64-bit. Click it, and your Windows 10 ISO will begin downloading immediately. Let it download alongside your Ubuntu machines. Downloads complete. Perfect. Now we begin creating our virtual machines. Back to VirtualBox. You should see the clean interface with no virtual machines yet. Click the New button at the top. A creation wizard opens. First, give your machine a name. Choose whatever name makes sense to you. This is your watchtower, your main SOC server. The name you choose is completely up to you. The folder path below shows where this virtual machine will be stored. The default location is fine, unless you want to use a specific drive. Leave it as it is for now. Now comes the critical part. ISO image. Click the drop-down and select Other. Navigate to your Downloads folder. Find the Ubuntu Server ISO you downloaded, select it, and click Open. Watch out for this trap. Below the ISO selection, there is a checkbox that says, Proceed with unattended installation. Make absolutely sure this box is unchecked. If you leave it checked, VirtualBox will try to auto-install Ubuntu with default settings, and you will miss crucial configuration steps that we need for security work. You will notice the section below it becomes disabled. That is exactly what we want. The next section is about hardware allocation. This is where you tell VirtualBox how much power to give your watchtower. Before you start moving sliders, I need to tell you something important. The resources you allocate depend entirely on your host computer's specifications. I have written complete details covering different scenarios. You can read this in the description below and choose the configuration that matches your system. If you're confused, drop a comment and I'll help you personally. For my system, I am allocating 8 GB of RAM and 4 CPU cores to this server. This works for my setup. Now the next section is hard disk size. I am setting this to 50 GB based on my system. Choose the size according to your system specs. You can read the description for guidance. Everything is set up. Click Finish. Your Watchtower virtual machine now appears in VirtualBox. Now we are creating our Ubuntu Desktop machine. Click New again and name this machine whatever you like. This is your DevOps engineer's workstation. Select the Ubuntu Desktop ISO you downloaded. Make absolutely sure Proceed with unattended installation is unchecked. For this workstation, we are giving it slightly fewer resources than the server, because it is an endpoint, not infrastructure. According to my system specifications, I am allocating 4 GB of RAM and 2 CPU cores. Again, check the description for your specific scenario. For storage, I am choosing 50 GB. Click Finish. Your second machine now appears in VirtualBox. 2 down, 1 to go. Click New one last time. Name this machine appropriately for a Windows workstation. Select your Windows 10 ISO and uncheck Proceed with unattended installation. For Windows, I am also giving it 4 GB of RAM and 2 CPU cores, the same as the Ubuntu Desktop. But for storage, Windows needs a bit more room, so I am setting it to 60 GB. Windows 10 itself takes up more space than Linux. Click Finish. Perfect. Look at your VirtualBox window now. 3 virtual machines sitting there, ready and waiting. Ubuntu Server, Ubuntu Desktop, and Windows 10. Your entire SOC infrastructure is created, but not yet deployed. Now comes the crucial network configuration that makes everything work together. In VirtualBox, on the left sidebar, you will see a network button. Click on it. If you don't see it there, you can open it by clicking File, Tools, Network. This will open the host-only networks interface. By default, there will be one adapter. If not, you can create a new one. To see more information about the selected adapter, click Properties. The Adapter tab shows the IPv4 address and the network mask. Now click the DHCP Server tab. Make sure Enable Server is checked. You will see the server address, lower address bound, and upper address bound. Make sure everything matches the configuration I'm showing you. These settings allow automatic IP assignment to your virtual machines in this network range. If you had to change anything, that's completely fine. But I recommend using the same configuration as mine for consistency. Our host-only adapter is now ready. Now we apply this to our virtual machines. Click on Settings for any of your virtual machines. Go to the Network tab. You will see that Adapter 1 is already enabled and set to NAT. Perfect. This gives your machine internet access. Leave it exactly as it is. Now click on the Adapter 2 tab. Check the box for Enable Network Adapter. In the Attach to dropdown, select Host-Only Adapter. The remaining settings are fine by default. Click OK. Your machine now has two network adapters configured: NAT for internet access and host-only for internal secure communication. This is exactly what a real SOC server needs. Repeat the same process for all remaining machines, exactly the same way. Make sure all three machines have identical network configurations: dual adapters, NAT, and host-only. Now we can finally start installing the operating systems. First, we will install our Ubuntu Server machine. Click Start. A new window opens. Press Enter when you see Try or Install Ubuntu Server. The screen fills with code, lines flying past. This is normal. Ubuntu is loading. After a moment, you will reach the installer screen. The language selection appears. Choose your language and press Enter. Keyboard configuration comes next. The default is usually correct, so just press Enter again. Now it asks for the installation type. You will see Ubuntu Server and Ubuntu Server minimized. Keep it on Ubuntu Server and press Enter. Next is network configuration. You'll see your NAT adapter and your host-only adapter listed. Don't change anything here. Just press Enter. The proxy configuration screen appears. Unless you are behind a corporate proxy, leave this blank. Press Enter. Ubuntu will now test mirror locations to find the fastest server. Wait for this to finish, then press Enter. Now comes a very important part. If the installer says a new update is available, update the installer. Do not skip this step. If you ignore it, the installation may fail. Updating can take a little time. Next, Ubuntu will guide you through storage setup. The guided storage option is already perfectly configured, so just press Enter to continue. You'll then see a confirmation of the storage layout. Press Enter again to approve it. The installer will now ask for your profile setup. This is where you choose your server name, your username, and your password. Pick names you'll remember, because you will use these credentials throughout the entire series. Press Enter when done. The Ubuntu Pro screen appears. Skip it by pressing Enter. Next comes a critical step: SSH setup. Select Install OpenSSH Server by pressing Enter. This is essential because SSH allows remote access to your server, exactly how real SOC analysts work. Now move to Done and press Enter. You'll now see the featured server snaps screen. We don't need any of these right now. Press Enter on Done. The installation begins. Ubuntu will copy files, configure system services, and prepare the base environment. This may take a few minutes depending on your system. When the installation is complete, you'll see Reboot Now. Press Enter. You may see a message about removing installation media. Just press Enter again. The screen may briefly go black. After reboot, your Ubuntu server is running successfully. Wait a few seconds for everything to initialize, then log in using the credentials you created. Type IPA and press Enter. This command displays your network interfaces. Look at the output carefully. You will see LO, which is the loopback interface. Below that, you will see ENP0S3, which is your NAT adapter with an IP address. You will also see ENP0S8, which is your host-only adapter, and look at that, it already has an IP address. This is your watchtower's address on the secure internal network. This is perfect. Both network adapters are active and configured automatically. Minimize this window and keep the server running. We're moving to the next installation. Select your Ubuntu Desktop machine and click Start. The machine boots. When you see Try or Install Ubuntu, press Enter on Install Ubuntu. The graphical installer loads. It is much friendlier than the server installer, but we are still going to make smart choices here. Choose your language and click on Install Ubuntu. The keyboard layout screen appears. The default option is fine. Click Continue. Now comes an important screen. Installation type. You will see normal installation and minimal installation. Choose minimal installation. This is critical. Minimal installation only includes the essentials. No games, no Office suite, no unnecessary software. This keeps your virtual machine light and focused on security work. Also check the box for Install third-party software for better hardware support. Click Continue. The installer will now ask about disk partitioning. Choose Erase Disk and install Ubuntu. Remember, this is a virtual disk. It is not erasing anything on your real computer. Click Install Now. A confirmation dialog appears. Click Continue. Next is the time zone selection. Pick your location and click Continue. The user creation screen appears. Set your username and password. Choose credentials you will remember. Click Continue. Installation begins. Ubuntu Desktop starts copying files and installing packages. You will see a slideshow with Ubuntu features. In the background, the system is also configuring your network adapters automatically. When installation is complete, click Restart Now. The machine will reboot. Press Enter if the installer asks you to remove installation media. Ubuntu Desktop will load and show your login screen. Enter your password and log in. You are now inside a clean Ubuntu Desktop environment. This is your DevOps Engineer workstation. Open the terminal. Type IPA and press Enter. Look at the output. You will see your network interfaces. Find the one that starts with ENP0S8. This is your host-only adapter, and it will have an IP address. Perfect. Your DevOps workstation is now online with proper networking. Minimize this window and leave it running. One last machine to go. Select your Windows 10 machine and click Start. The familiar Windows logo will appear. After it loads, you will see the language selection screen. Choose your language and click Next. You will then see a large blue Install Now button. Click it. The product key screen appears. Click I do not have a product key. We are using evaluation mode, which is perfectly legal for learning and testing. Next, the Windows 10 Edition selection appears. Choose Windows 10 Pro. This version includes features that make enterprise simulation more accurate. Click Next. You will now see the license terms. Check the box and click Next. The installation type screen appears. Choose Custom Install Windows Only, because we are doing a fresh installation. The drive selection screen appears. You will see unallocated space. Click New to create a partition. Accept the default size and click Apply. Windows will automatically create the necessary system partitions. Click Next. Windows installation begins. A progress bar will show files being copied. This process takes some time, and the machine will restart automatically. After the restart, Windows will show the Getting Ready screen. Then, it asks for your region. Choose your country and click Yes. The keyboard layout screen appears. Choose your layout and click Yes. When it asks if you want to add another layout, click Skip. Select Setup for personal use and click Next. Windows now encourages you to sign in with a Microsoft account. We are not doing that for this lab. Click Offline Account at the bottom left. Windows will try to convince you again, but click Limited Experience. Next is username creation. Enter a name for this user. Choose whatever makes sense for a designer workstation. Click Next. Then set up a password you will remember and answer the security questions. Click Next. When it asks for access to recent browsing data for Edge, click Not Now. Privacy settings now appear. This entire section is tracking and telemetry. Set all the switches to off and click Accept. When Windows asks you to customize your experience, simply skip it. Then the Cortana setup appears. Click Not Now. Windows will finalize your setup. After a short moment, your Windows 10 desktop will appear, clean and ready. Right-click the Start button and open PowerShell. Type ipconfig and press Enter. Look at the output carefully. You will see two network adapters. The first one is the NAT adapter. The second one is the host-only adapter for your Windows 10 machine, and it will have your internal SOC network IP address. Excellent. Your designer workstation is now online. Look at what you have accomplished. 3 virtual machines, all installed, all running, all with proper network configuration. Each machine has an IP address on your secure internal network. Your SOC infrastructure is alive. Now comes the final test. We need to verify that all machines can communicate with each other and with your host computer. This is critical. If communication fails, your entire SOC monitoring system will not work in future episodes. But before we continue, let me do something to avoid confusion. I turned off my host computer Wi-Fi. This way you can clearly see that we are working only on the host-only network, not the internet. You do not need to turn off your Wi-Fi. I am only doing this for clarity. On your host computer, open the terminal and type ipconfig. Look at the output under the second adapter. It will show an IP address. This is your host computer's address on the internal network. We now have 4 IP addresses. Time to test communication. Go to your Ubuntu Server window. You should still be logged in. Type ping followed by your host IP address, then type -C4 and press Enter. This pings your host computer. If you see the echo requests being received, everything is already working. But if you don't see any replies, do not panic. Windows is simply blocking the ping, and we just need to turn it on. On your host computer, open Control Panel. Click System and Security. Click Windows Defender Firewall. On the left, click Advanced Settings. The Firewall Management Console will open. On the left side, click Inbound Rules. You will see a long list. Scroll down until you find File and Printer Sharing Echo Request. You will see multiple entries. Find the ICMPv4 in, under the Domain and Private Profiles. Right-click each one and click Enable Rule. Both rules are now enabled. Go back to your Ubuntu Server window. Run the ping command again. Watch the output. You should now see replies, along with the latency values. Packet loss should be 0. Your Ubuntu server can communicate with your host computer. Now test the endpoints. Type ping, then your Ubuntu Desktop IP, then -C4, and press Enter. This pings your Ubuntu Desktop. Replies come back immediately. Communication confirmed. Next, type ping, then your Windows 10 machine IP, then -C4, and press Enter. This pings your Windows 10 machine. If this also fails, repeat the same firewall rule steps inside the Windows 10 virtual machine and enable the same echo request rules. Now we have confirmed that all machines are communicating. Your internal network is fully functional. Your Security Operations Center infrastructure is connected. There is one final touch that transforms this from a simple lab setup into a professional SOC environment. SSH access from your host computer to your watchtower. This is how real SOC analysts work. They do not sit inside virtual machine windows. Instead, they connect remotely via SSH using proper terminal tools. On your host computer, open a terminal. Type SSH, followed by your Ubuntu server username, then the @ symbol, and then your server IP address. Press Enter. The first time you connect, SSH will ask if you want to continue. It will show a fingerprint for the server. Type yes and press Enter. It will then ask for your password. Type your Ubuntu server password and press Enter. Watch what happens. Your terminal prompt changes. It now shows your username at your Ubuntu server hostname. You are inside your Ubuntu server, but every command is being typed from your host computer. Try a simple test. Type IPA and press enter. You will see the Ubuntu server network configuration displayed right there in your host terminal. This is professional SOC work. You are remotely managing your security infrastructure. Every command you type runs directly on the Ubuntu server, while you work from your comfortable host machine. This is how you will interact with your SOC throughout this entire series. If you made it this far, you have proven something important. You have the dedication and the focus to learn real cybersecurity. Most people quit when things get technical, but you pushed through and built something real. Drop a comment below telling me your watchtower is online. Share your experience. Did everything work smoothly, or did you face challenges? Your feedback helps me create better content for everyone. Until then, stay curious, stay ethical, and keep learning. This is TechSky signing off.